Fifth one, initial and boundary value problems. Actually, this definition we can discuss through problems. While once we start the problem solving differential equations, there only itself mentioned initial condition, boundary conditions. Okay, it's not a separate subtopic, it's a small definition only. First, to discuss with initial and boundary conditions. The condition in bracket S, in which the dependent variable and its derivatives are specified at 1 in bracket 2 or more value in bracket S of the independent variable comma is or oblique or called initial in bracket boundary conditions. A DE together with 1 initial conditions is called initial value problem, abbreviated as IVP in this 2. Together with boundary conditions is called boundary value problem. In bracket abbreviated as BVP. Now, whatever the differential equation given, let us say we got the solution. By using some method, if you find the solution and the problem containing some condition y of 0 is equal to 1 or given y is equal to 1 when x is equal to 0, okay, and y is equal to 0 when x is equal to 1. These type of conditions are called initial or boundary conditions. When should we say initial conditions? When should we call boundary conditions? Now look at the definition. Condition, conditions. Actually two definitions given in the same point. Condition, that is one condition, or 2 to 3 conditions, etc. In which, again this definition related to dependent and derivatives, in which dependent variable and derivatives specified. Okay, that means they have values at 1 or 2 or more. The dependent variable derivatives have some values, values means some constants, at 1 value of the independent variable or 2, 3, etc. values of the independent variable. If it is 1 value of the independent variable, such conditions are called initial conditions. If two or more values of the independent variable, such conditions are called boundary conditions. Okay, see, simple. Y of 0 is equal to 1, y dash 0 is equal to minus 1. What is y dash? It is a first derivative of y with respect to independent variable, say x. So what is the meaning in this? That is y value 1 when x value 0. And what is the meaning of this condition? Writing in elaborated form, okay, in detailed form. Y dash value minus 1 when x equal to 0. Here I didn't give that x is independent variable. Whatever the variable, I am denoting by x. In the problem itself you can identify the independent variable, but I am taking for understanding purpose x is independent, y is dependent. So here x value 0, x value 0. So x has how many values? Only one value, namely 0. These type of conditions are called initial conditions. Okay, these are called initial conditions. Okay, as independent variable x has one value 0. One value 0. Now similarly see, y of 0 is equal to 1 and y of 1 is equal to 0 are called, I am leaving the place. See, what is the meaning of y of 0 is equal to 1? Y value 1 when x is equal to 0. And what is the meaning of this condition? Y value 0 when x equal to 1. So x is an independent variable having one value 0, other value 1. So these are called boundary conditions example, simple example of boundary condition. Okay, here the independent variable x has two values, that is 0 and 1. Because the independent variable x has more than one value, such conditions are called boundary conditions. Okay, so a differential equation together with these type of conditions are called initial value problem or boundary value problem, depending on the conditions. So one example, d square y by dx square plus 4 dy by dx plus 4y is equal to 0, comma, with y of 0 is equal to 1 and y dash 0 is equal to 0. So independent variable x value 0, x value 0, x has only one value. So these are called initial conditions, simply abbreviated or denoted by IC, initial conditions. And such type of problems, such type of conditions with the differential equation is called initial value problem. Okay. D square x by dt square or d square y by dx square plus 2 dy by dx plus y is equal to 0 with y of 0 is equal to 1 and y of 1 is equal to 0. So here independent variable x has one value 0 and other value 1. So these type of conditions are called boundary conditions. CY and S. Such type of differential equation with these conditions is called boundary value problem. So these are the main definitions. Now we are going to start first order differential equations, how to solve that differential equation first order, linear or non-linear. Definition: an equation EQ of the form dy by dx is equal to f of x comma y, say equation 1. Is called a first order and first degree differential equation. What is the highest derivative? 1, first order. The power of this highest derivative is 1, first order, first degree differential equation. And remember this, not all the equations of type 1, that is differential equations 1, not all equations can be solved. Okay, only those among them can be reduced to the following categories which are having standard methods. There are some categories, that is the types of the methods having some standard procedures. Okay, but don't think that every problem of that type equation 1 can be solved. Okay, only but in numerical methods, see Euler's method, Runge-Kutta method we have done. Whenever initial condition given, then we can solve every problem through that methods, but gives particular solution only, not general solution. Okay, so and before approaching here, I told you already long back, I mean today in the first session, maximum problems solutions related, the general solution or solution. So first of all, what is solution? These are simple definitions. You can see from textbooks or our material. Okay, it's given in a good language. Okay, not required to generally explain. You can easy to understand. Generally, this solution means it is related to any other chapter, not only differential equation. A solution of a differential equation means that it is a relation between the variables free from derivatives and satisfies the given differential equation. Solution should not containing any derivatives. Okay, and it is a relationship between variables. What are variables? Dependent and independent variables. That relation must satisfy the given differential equation, then only the relation is called solution. In this solution, generally we are seeking about general solution or particular solution, rare case particular solution. Now what is general solution, particular solution? A solution is called general solution if it contains arbitrary constants, that is number of arbitrary constants is equal to order of the differential equation. A solution is called general solution if the number of arbitrary constants in a solution is equal to order of the corresponding differential equation. Then the solution is called general solution. Particular solution is obtained by the general solution for giving particular values to the constants. Once you get general solution, it contains some arbitrary constants. Any numbers can take, that is C1, C2, etc. they are denoted by. In the general solution, give some values to the constants C1, C2. The solution so obtained is called particular solution. Okay. For example, see, if I take a simple equation d square y by dx square y is equal to 0. This is equation 1. Of course, this is not related to first order. The solution, general solution related to any differential equation. Okay. So, I am taking y is equal to sum c1 cos x plus c2 sin x. This is 2. Now, if I put here in the left side equation, check whether you are getting 0 or not. Right side is 0, left side is sum. So, now I am going to check this equation to y value is a solution of equation 1 or not. So, this is a second order differential equation. Okay, is differential equation dE. What is its first derivative? dy by dx minus c1 cos x derivative minus sin x derivative plus cos x, c2 cos x. What is second derivative? d square by dx square, sin x derivative cos x derivative minus sin x. So, minus c1 sin x minus c2 cos x. Now, therefore, 1 implies, just substitute these conditions in equation 1. Minus, second derivative is minus c1 sin x minus c2 cos x plus y. What is y value? c1 cos x. Sorry, here I have done a big mistake. This is first derivative, sin x derivative cos x derivative minus sin x. C1, C2 representation symbols I have written same, but a small confusion here. Now, what is second derivative? In equation 1, substitute d square by dx square and y value. So, this implies minus c1 cos x minus c2 sin x plus y value. Y is c1 cos x plus c2 sin x is equal to 0. Both are cancelled here. So, therefore, we got 0 is equal to 0, which is true. Okay. What is the meaning of which is true? So, this is equation 2 is called the general solution of equation 1. This is first of all satisfied. Anything satisfies the equation, that is called solution. In this solution, how many arbitrary constants? C1, C2. What is the order of the corresponding differential equation? Second order. So, number of arbitrary constants equal to 2 is equal to order of the differential equation. So, this is called general solution of this differential equation. Now, if I take only y is equal to cos x. So, now if you substitute here in the left side, second derivative of cos x first derivative is minus sin x next derivative is minus cos x plus y value I took cos x. So, this is minus cos x plus cos x is equal to 0. So, this is also a solution, but called particular solution. Why? This solution is obtained from general solution by taking C1 is equal to 1, C2 is equal to 0, which is obtained from equation 2 by giving C1 is equal to 1, C2 is equal to 0. In the general solution, if C1 is equal to 1, C2 is equal to 0, then this is obtained. So, this solution is called one of the particular solution. General solution is only one, unique for any differential equation, but particular solution are many depending on giving the values for C1, C2. C1, C2, C3, etc. First order equation whose solution containing one arbitrary constant. Second order differential equation whose solution containing two arbitrary constants, and so on. The following types have the standard methods to solve equation 1 in general. I told you not every problem, whatever the following types, categories I am writing, okay, we are solving that equation 1, but don't think that every problem of equation 1 can be solved by the following categories. Only some differential equations cannot be solved. Now in this one, variables separable form, simply written or abbreviated as VSF. 2, linear equation method, which we already discussed as above, previous session, linear equation method. 3, linear equation definition, but I didn't discuss their method. Now we are going to discuss one by one type with the standard methods. Standard method means they have some procedure to get the solution of this equation 1. Next, Bernoulli's equation. 4, exact equation. The first one, variables separable form. A DE, that is equation 1, is said to be in variable separable form VSF if it can be expressed as fx into dx plus g of y into dy is equal to 0, or fx into dx is equal to dy by dx equal to fx divided by g of y. Come to equation. Now, if the given equation, this is standard type, this equation can be put in the form of x terms alone multiplied with dx, y terms alone multiplied with dy. That is, it is the name itself is there, separable, separated. So x terms and y terms, earlier it is called combined form, joint form. Now this joint form, that is the function f of x comma y, should be split into two factors. One is x terms alone, other is y terms alone. Once it is split into x terms alone, y terms alone, then we can write that equation to this form, fx dx plus gy dy, or left side is dy by dx, right side is combined x comma y, now it is separated, x terms alone divided by y terms alone. Okay, that is. So it is means that if it is two variables x comma y in the given equation, x terms multiplied by dx plus y terms multiplied by dy, plus or minus. If it is minus, that shifted to right side becomes gy dy only. Okay, so plus and minus is not the matter, symbol is not the matter, but fx means x terms alone, which is multiplying by dx, y terms alone, that is gy denoted by gy, which is multiplying only dy, then only the given equation is called variable separable. Now what is the next step? Finding the general solution by doing just integrating on both sides. Integrating both sides of equation 2, we get this is integral fx dx plus integral gy dy is equal to c. This c is arbitrary constant or constant of integration parameter also, is called the general solution. In short, it is also denoted by GS, is called the general solution of equation 1. Equation 1 means given differential equation. Okay, this is the general solution after integrating, because it is a first order equation, its solution containing only one arbitrary constant, that is called general solution. Example 1. This question asked in 2015. The general solution GS of the differential equation dE dy by dx is equal to 1 plus cos 2y divided by 1 minus cos 2x is there. Solution or answer. So it's already right side that variables are separated, y terms alone dividing by x terms alone. Okay, so the differential equation dE can be written as just shift this dx to the right side and bring that right side numerator y terms to the left side. You will get variable separable form. dy by 1 plus cos 2y is equal to dx by 1 minus cos 2x. Now, just see what I have done. Dy is already in the numerator, so I keep that dy by dx as it is in that position. Dx should be sent into right side, because if you see the standard form of variable separable, how I wrote, dx dy should be in the numerator, dx multiplied only x terms, dy multiplied only y terms. So shift, bring that 1 plus cos 2y y terms to the left side and shift this denominator dx of the left side to the right side. You will get directly this form. So this is VSF, variable separable form. After that, integrating both sides, we get now left side 1 by 1 plus cos 2y dy is equal to integral 1 by 1 plus cos 2x dx plus first add c, normal constant. Now before finding the solution, you immediately think, while writing this step only, you decide or think which method is applicable in integration. So, is it formula directly, which I provided earlier, long back, that is max 1 calculus? It's not direct integration formula. It has some simplifications with the help of trigonometric formulas. 1 plus cos 2a, both denominator looks like 1 plus cos 2a. What is 1 plus cos 2a? 2 sin square, 2 cos square a, sorry. 1 plus cos 2a is 2 cos square a. 1 minus cos 2a is 2 sin square a. So, using that, 1 by 2 cos square y dy is equal to integral 1 by 2 1 by 2 sin square 2 cos square x, 1 by 2 cos square x. Oh, this is minus, kindly excuse me. So, 1 minus 2 cos square 2 cos 1 minus cos 2a, 1 plus cos 2a is 2 cos square a, 1 minus cos 2a is 2 sin square a. So, now the second denominator, that is 2 sin square x dx plus c. So, here both integration containing half constant multiplication. Half is a constant multiplying. So, take outside. So, what I am doing from the above step onwards, instead of c, I should write c by 2. So, later I will tell why. This first I can cancel all the side, both sides, left side and right side half cancelled. Now, this is integral secant square y dy. 1 by cos square is secant square. 1 by sin square is cosecant square. So, this is cosec square x dx plus c. Half is cancelled. Why? Even if you start from plus c adding, the last step, the solution may not be in your options A, B, C, D. Then what you have to do? Go back to that arbitrary constant, rearrange or adjust that constant into to get the solution in the options, to get the solution in one of the options. So, what is rearranging or adjusting means? Sometimes you can take, we need to take minus c or c by 2, sometimes log c. If you get all integration terms after integrating log x, log y, then take log c. Okay. So, integral secant square y is tan y. Integral cosec square x is minus cot x plus c is the GS, general solution. Since 1 plus cos 2a 2 cos square a, 1 minus cos 2a 2 sin square a. And this question asked 2 marks in 2007. The solution of dy by dx is equal to y square comma y of 0 is equal to 1, initial value given, is bounded in the interval option A minus infinity less than x less than infinity, B minus infinity less than x less than or equal to 1, C x less than 1 comma x greater than 1, D minus 2 less than or equal to x less than or equal to 2. Here the solution means y variable dependent variable is bounded. Bounded means we used the terminology, we explained the terminology in max 1 class, improper integrals. Bounded means finite. So here we are going to find the solution, that is y variable, for what values of x? Some intervals given, all the options. So bounded means finite. Y value finite for what values of x? That is the question required. Now, so dE can be written as easy to separable. Bring that y square term to the left side, shift that dx to the right side, written as dy by y square is equal to dx. So this is variable separable form VSF integrating, comma, we get 1 by y square is y to the power minus 2 dy integration integral dx plus c. X power n integration is x power n plus 1 by n plus 1. Using that simplifies to minus 1 by y is equal to x plus c, equation 1. Since integral x power n dx is equal to x power n plus 1 by n plus 1 if n not equal to minus 1. Now use the given condition. What is that condition? Y of 0. Given y of 0 is equal to 1. That is y value 1 when x value 0, comma 1 gives, substitute there in the equation 1, minus 1 is equal to c. Therefore equation 1 implies, now go back to equation 1, substitute c value, minus 1 by y is equal to x minus 1. From this find y value is equal to y is equal to 1 by 1 minus x. So this is called solution. Now this solution is defined for every x value, is finite for every x value except the denominator becomes 0. When the denominator becomes 0 by putting x equal to 1, so is finite. Finite means that is you call bounded also. Bounded if 1 minus x not equal to 0, that means x not equal to 1 implies x less than 1, comma x greater than 1. Whenever the denominator becomes 0, that y value becomes infinite. Infinite means unbounded, finite means bounded. You compare like that word. These words we discussed in long back, calculus, in integrations, max 1 chapter. So here x minus 1 not equal to 0, then you will get finite solution. X not equal to 1. Not equal to 1 means either less than 1 or greater than 1. So answer is option C. Dependent variable is called solution in terms of independent variable. Have a break. If you have any doubts, please post the questions in detail for the current topic, differential equations.